All right, welcome back everyone. So last time we began talking about the JavaScript programming language. And as we discussed, the JavaScript programming language is just a language that allows you, the developer or the programmer, to specify a set of instructions that then at some point get turned into machine code that then the processor can understand and execute or run, right? So we talked about a few things as far as JavaScript. We also talked about how to execute JavaScript. And one way to do this would be to use a script tag inside of your HTML page. So basically what happens is when the browser is reading your HTML and encounters the script tag, it says, oh, I have to run some code now. I have to execute some JavaScript. And it will do that either by reading the content inside the script, if you put the code inside the script tag, or it will check to see, is there an src attribute, a reference, if you will, to another file which ends in .js, thereby symbolizing that it's a JavaScript file. It will load that into memory and then execute it, right? And by executing, I mean it will turn it into machine code and then run it on the processor. Now, when we dove into the JavaScript programming language, the first thing we encountered was this console.log, which is a function, but you don't know what that is. So for now, just assume that it's some magic trick that takes the content that is inside the parentheses, this stuff here, and then prints it to the console. And remember, in your browser, the console can be found by right-clicking, go into Inspect. That will open up your development tools in Chrome. And then you go to the Console tab, and that's where you'll see the output of all your console logs. In this case, though, just to make it easier to explain to you, what I've done is I've redirected that console log to not be written to the console, but instead to be written just below the text editor, which is why all the console logs, the result of which, appear just below. Is this part clear? Are there any questions up until this point? Okay, good. Okay, the next thing that we talked about was that JavaScript has values. That is to say, a way of representing data. Okay? Now you can represent different kinds of values, different kinds of data. So for example, this is a value. It's a number, 737. Let's print this value just so that we can see that we can, for example, print the value. So we do, again, this magic console.log. And we see that it prints 737, which of course is a value. And specifically, what kind of value is this? It's a number. Exactly, it's a number, right? It's a numeric value. There are other kinds of values that we can have other than numbers. We can have strings. Do you remember how we can make a string? Exactly, we quote, and we can use either single quotes like that and type whatever we want, thereby making the string, or double quotes. Is there a difference? There is no difference. They're exactly the same in every way. Yeah. So there you go. So you see the result of that. So this is just some string. Yes?
What happens if you don't put the...
Good question. So remember this. When you write English, right, there are certain grammatical rules, right? A syntax, if you will, that you have to follow so that the reader, when they read what you wrote, can better understand what you wrote. Imagine writing a book without any periods or any parentheses, or capital or lowercase, right? It's just like stuff. It's much harder to understand exactly what you meant, right? And in fact, in some cases, what you meant may be, people may misunderstand what you wrote, right? So what you want to do is be very precise and match the rules of the grammar, right? The rules of the language. The rules of this language, of JavaScript, say if you want to make a string, fine. But you have to end the string to say that this is where the string starts and this is where it ends. If you do not, notice how nothing printed? Because an error was raised. An error specifically saying, wait, something is weird with what you wrote. It doesn't match the grammar. It doesn't match the rules of the language. It doesn't match the syntax. It's a syntax error, in fact. Okay? So to answer your question, you have to put the quote in order to fit with the rules of the language. Go.
I was thinking about, like, will it transfer the letter values to numerical numbers? That kind of, like...
Will it try to do a random trick?
Yeah.
Okay, so when you make a mistake in a language, the language designers, that's actually the people who designed the compiler. So here's what happens when you execute your code. The first thing is there's a parser. There's a program that tries to read what you wrote and try to understand what you wrote. That is the thing that will throw an error, a syntax error, saying, wait, what you wrote doesn't match the rules that I expect, and it will throw a syntax error. If it completes and it says, oh, it actually matches all the rules, even if you made a mistake, as long as the mistake is within those rules, it will then continue and try to execute it. That is to say, first translate it into machine code and then run it on the processor. So if the mistake that you wrote is legal, it's your problem. Yeah, you made a mistake and it will do something random. So the answer to that, of course, is don't make a mistake. It's literally that simple. All you have to do when writing thousands of lines of code is never make a mistake. Because if you make a mistake, the computer has license to do the worst possible thing at the worst possible time. Welcome to the world of software engineering. Okay, so we saw that we can make numbers. We saw that we can make strings, like that. Oop, not like that. Like that. There you go. Okay, well, the other thing that we saw was the value that we saw was Boolean values, right? There were two Boolean values. You guys remember what they are? True and false. True and false. Very good. So you can have this be true, and it prints true, or you can have it be false. Cool. The next thing that we talked about were variables, right? So variables were these containers where you can put values, right? And then you can use those containers as basically aliases for that value. So in your head, whenever you see that variable, you can replace it with the value when you're kind of reading your program. So think of it this way. First of all, what's the syntax for making a variable? Const, good. Or okay, don't mention var. I'll say that later. Const, then what? The name of the variable. Why do we need a name for the variable? Yeah, think of it this way. Why do you need a name? So people can refer to you, right? They can say, hey, Bolos. Me? Yeah, you. Okay, so you need a name to refer to things, right? Same thing. You have this box that you can put things into. It needs a name so you can refer to it, right? Okay, so let's give it a name. Let me just give it a bad name, like A, and let me set that to, like 26. Okay, now you might say, okay, you have a value 26 in A. But what is A? What is A supposed to represent? A doesn't tell me anything. It's just a letter. It's better to give it some sort of a name, a label, so that you can understand the value that's inside it. The fact that it's just a number isn't enough. What kind of number? Why is it there? Why is it in my program? Maybe I'm trying to represent someone's age. In that case, I would change the name of the variable to age. Now it's clear. Now later, much later, when you write a lot of code and you see age, you go, that means age. I'm going to use that to compute, if someone can walk into a bar or something. I don't know, right? Whereas if I just saw A, B, C, Z, what is that? I have no idea what that is. So then I have to go and try to figure out why that's there, right? So naming your variables is very important. Give things names that make sense, that describe the content that is inside. Okay, cool. So we made this variable, right, this container, inside of which we put 26. And now we can use age anywhere we want to mean 26. So if I, console.log age, it will print 26. Because again, it's the same thing as doing this, right? It swaps underneath. I can do plus 4, right? Well, age is 26, so 26 plus 4 is 30, right? So now you're getting a sense of what variables are. They're just these aliases for values. And we have as values numbers, strings, boolean. There are others that we'll come back to later, but those are the three I want you to know for now. We learned that in programming we have arithmetic operators. These are the operators that you know and love. Addition, subtraction, multiplication, and deletion. And if you use these with numbers, you get the output that you expect. In other words, if you do a plus with two numbers, what you expect is that it adds them together. And that's exactly what happens. However, the plus operator, specifically the plus operator, is overloaded. And what we mean by overloaded is it can do more than one thing. So one of the things it can do is add two numbers. Fine, we got that. The second thing it can do is if either side is a string, at least one side. If both sides, fine. If either one of the sides, also, it will stick them together and produce a new string. So here, age is a number, but if we add age to some text, like hello, it will take age, take the hello string, stick them together, creating a new string, which will have in it 26 hello, those characters. And then in this case, we're printing them, but we could have easily just taken that result and stuck it into another variable called age hello. There you go, and now I can print age hello, or further concatenated with haha. Any questions up until this point? There was a question asked earlier about this. And the question was, how come 34 is not being added to 5? Right. What this means is a string is just a series of characters. It's not executed, it's just text. So in this case, this means I'm about to start a string, this means I'm about to end a string, and this is just characters inside of the string. They don't do anything, it's just text, like someone's name, right? If I wanted to actually run this, I would put it not as text, but as actual values. The number 34 plus 5. And now, yes, I will get 39. Does that make sense? Cool. Okay. Any questions up until this point? Good. Oh, yes, sir. The modulo, yeah, the modulo. Heto. So the question is, will we study the modulo operator, which takes the remainder of a divisor? We'll talk about that later. It's just another operator. That's all that is. Okay, good. Other questions? None? Okay, cool. So the other thing that we talked about was Boolean values, right? Or Boolean operations. So we talked about and. How do you represent and in code? Do you remember? Two ampersands, basically these things. That is an and. What's that? Or. And what's this? Not. Cool. So that means if I have a const, some value, whatever, a for now, because it's just an example, it's a bad name, of course, and I set that to true, and then I have another variable b where I do not a, what is the value of b? Okay, so let's go through this. So a we know is true. The result of this operation here will flip it, making it false. The result of that operation will flip it again, making it true. The result of that operation will flip it back to false. And therefore, the value of b is false. Does that make sense? Okay, so then let's do this. What if I were to do, let's see, a or true? True. So a is true and b and true is true. So therefore, and if it's or, then at least one side has to be true, right? What if I did this? B is true, right? Because at least one of the sides is true, in this case, the right side. Fine. What if I were to do that? False, because and implies that both sides absolutely have to be true. Otherwise, it's assumed to be false. And so the result of running this operation is false. Right? So this gets turned into that. That to that. That to that. Got it? Cool. Okay, cool. So we understand Boolean logic. Yay. And, or, and not is all you'll need for this class. Okay, now let's talk about something else, conditionals. So you're writing steps, right? Let's consider writing steps to explain to someone how to buy coffee at Green Bean. Okay, so you say, all right, if you're in this class, assuming the class is over, get up, go out the door, take a left, take a right, go into green bean. As you're walking, if you encounter someone, right, do like a left straight, right? Don't, right? Like if you're walking and someone is walking towards you, if someone is walking towards you, you might want to, right? Something like that. Or if there's someone to their left and there's no room, you might want to go this way and then that way. True? Okay. So when explaining something to someone, that is to say a series of steps or an algorithm, it's important to consider various scenarios. In this case, the scenario is there someone in front of you that you have to walk around, right? If there is someone in front of you, walk around. If there is not someone in front of you, keep going, right? Okay, so we need some way in our programs to say if. How do you suppose we can write if? We write if. It's good, so we do if. Okay, so imagine we have some const age that is, okay, let's say 22. So let's say we have an age of 22. So somewhere, somehow, we find out that the user of our program is 22 years old. Actually, you know what? Let's do this. Let's say they're 12. Okay, good. Now you want to say if their age is greater than 18, or greater than or equal to potentially at 18, or 21. How about that? 21. Then console.log. Sell them alcohol. Okay. Else, console.log, no way, go home. Okay, so in this case, look, the input, or some value, some variable in this case, is age, which says that the person is 12 years old. And we say if their age is greater than or equal to 21. You remember these operators? Greater than or equal to, not equal to, equal to. Well, this is where you can use them. You can say, well, if age is greater than or equal to 21, then let's give them beer. Fine, whatever. But if they're not, that is to say their age is less than 21, then we do not serve them beer. We say, go home, grow up, come back later. Right? Okay, this is similar to when you're walking. If there is someone in front of you, take a left, right? If there is not someone else, that is to say, if they're not in front of you, you can keep walking, right? So in this way, think about it. All a program is just a series of steps, right? Do this, then do this, then do this, then do this. So we need these kinds of conditionals to say, but if this is so, do this, else do that other thing. Makes sense, right? Now, you might notice that the syntax or the way I wrote this is as follows. I wrote if, because I want to know if. That's easy. Then I open the parentheses and I write the expression that will return a Boolean value. If it returns true, the code inside of my if statement, that is to say the code that is inside of this curly and that curly, will run. So this curly means start. This curly means stop. This is the beginning, this is the end. So the code inside of these two things will only run if this is true. If it is not true, that is to say else, then the stuff between these two will run. That is to say that code right there. Does that make sense? Okay, raise your hand if it does not. Really? Everyone understands this? I don't believe you for some reason. Okay. All right. There are a few things. First of all, you don't need the else statement. This is also okay. And then you can just keep writing your code here. Fine. So in this case, this will run only if age is in fact bigger than 21, and then the rest of your code will run either way. Else will only run if age is less than 21. So the code in here, whatever you write in there, will only run if age is in fact less than 21. However, now suppose you want to break it down into different ages. So you want to say, if they're over 18, but they're under 21, if they're 18 or older, that is to say they're mature, but they're not 21 yet, we're not going to serve them beer, but maybe we can still let them into the restaurant, right? So at 18, you can come into the restaurant, but if you're 21, you can buy beer. Okay? So in that case, what we need is a few if statements, right? If they're 21, give them beer. If they're 18 to 21 inclusively, 18 but less than 21, then we can let them in but not give them beer. For all other cases, we can't let them in because they're too young. Fair? So how can we do this? Well, we can just write a bunch of if statements. We can say, okay, if their age is bigger than 21 or equal to or bigger than 21, then we'll give them beer. Fine. If their age is less than 21, and their age is larger and equal to 18, in this case, we can console.log let them in. Haha. Okay. In all other cases, that is to say, if age is less than 21, yes, thank you. If it's less than 18, this is the case where we're not going to let them in. Console.log, sorry, go home. Okay. Is that clear? Now, notice how, so the program is going to execute from top down, right? So the first thing it will do is it will go there. It will say, okay, we're going to put 12 into age. It's going to go here. It's going to say, okay, if age is 21, do that. But it's not, right? So it skips it. It says if age is less than 21 and age is 18, it's not, skips it. If age is less than 18, it goes inside those curly braces and then runs that code, that console.log, which will say, ta-da, sorry, go home. Now, if they are, say, really old or older, sell them alcohol, whatever, no problem, right? And if they're, of course, if they're, 19, we'll let them in, but, we can't give them alcohol. Okay so far? Okay, now it turns out that, now suppose they are in fact more than 21. So suppose they're 81 years old. Okay. If they're 81 years old, here's what the program will do. It will put 18 into age, fine. This is an assignment, or assign 18 to age, whatever. Then it will come here and it will say, is 81, my apologies. Is 81 greater than or equal to 21? Yes, right? So it will go in here and execute the code inside of the curly. So it will print, sell them alcohol. Oh, shit, sorry, S-E-L-L, whatever. Okay, S-E-L-L, alcohol. Then it will go here. See, I wrote seal. Then it will go there. It will check to see if age is less than 21 and age is greater than 18. It's not, right? So it will skip this one. It will then check this one, which is false. It will skip, right? Notice that after it ran this one, it still looked at this one, and then again it still looked at this one, right? Well, there's a sort of a better way to do this. Remember else?
You can put that in the else.
Exactly. You can do this. Watch. So what this means is very simple. If this is true, run it. Else, check the next one. If it's true, run it. Next one. If it's true, run it. So if it's true and it runs, it just jumps out. After, it doesn't then check all the others because else doesn't work there. You're right. So what we could do then, because in all other cases, because if they're not greater than or equal to 21, and they're not between 18 and 21, right? In all other cases, we don't give them beer. So we could also do it this way. So in this case, this will run only if all of these other ones don't run. So it will first check, is this true? If yes, run it. If not, else, if, check this one. If true, run it. If you run it, you're done. You jump out, you just keep going. From here, you keep going. If it's not, you go to the else if dot, 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 and you keep doing this until you're done. So think of it this way. Again, in that walking scenario where you're walking into green bean, if there is a person in front of you as you're walking, go left. But if there's a person to your left, go right. Yeah, don't actually, okay. If there's someone in front of you, actually it should be this. If there's someone in front of you, look left, right? If there's no one there, then go left. In that case, what you really want to do is say if, someone is in front of you, obviously this would be expressed as Boolean. This is not code. This is just me explaining to you. If someone is in front of you, then you do if nobody to the left. Here you would say go left. Else if nobody to the right, go right. Else panic. Nowhere to go. Okay, right? So you can see how you can kind of chain these if statements to say, okay, in this scenario, I want to do this, and in that scenario, I want to do that. Okay? So we have if statements, these conditionals, these if this, then being the curlies, the code inside that will run, and you can put there whatever you want. With me? Mm-hmm. Raise your hands if this is kind of fuzzy to you and you want me to explain it further.
Why it is
Uh-huh.
red?
Why this is red? Ah, okay, cool. So let me explain. Right? Yeah, no, I know. You're asking about this, right?
No, the first one.
This one?
Someone is in front of you.
Oh, this. Okay, remember, this is not code. I just wrote like just text, pseudocode. This is not legal syntax. You can't. This is not code. So the reason why is because in is a reserved word in JavaScript and is trying to syntax highlight it. Okay, maybe I confused you further. Forget what I just wrote. Okay, let's stick to age. Okay, that's good. Remember how an editor tries to highlight code, right, to make it easier for us to read? That's why. In was a reserved word, which is why it changed color. In is part of JavaScript. That's why. Okay, so forget the text that I wrote. We have conditionals. If age is greater than 25, do whatever. By the way, quick thing. If you ever see me do this and then write code, this is not code. What this means is it's telling the parser, the thing that's trying to run your code, skip this. It's just text. This is called a comment. Why do you suppose we have such a thing in the language, a comment? Yeah, so you can kind of write what's going on, right? So you can say, for example, up here, I can write a comment. This is so that, people who are underage don't come in. And then the actual code. So this is just human readable. It's for us as programmers to read. This doesn't run. This does not execute. The processor does not know about this. This is just a comment for us to understand what's happening. Okay?
In some cases, we can use that to disable one part.
Yeah, so in the same way, you can also just, if you do this in front of code, you are basically shutting that code off. It will not run because it's commented. The parser will skip over it. In some cases, if you're doing experiments, yeah, and you don't want to delete and then undo or whatever, you can just comment, yeah, and then decomment later or uncomment. Does that make sense? Again, a comment is just some text that you can put in that the program doesn't run. It's just for you to use to read. That's it. Is that clear? Yes? A bunch of blank faces. Okay. All right. So then one more thing that is important for us to know. In JavaScript, so we know that there are Boolean values, right? There is true and there is false. Fine, that makes sense, I think. And then you can do Boolean operations like and, or not on those true. And you can also put them in if statements. So if true, it goes and it executes the code. If false, then it skips the if statement, right? So far, this kind of maybe makes sense. In JavaScript, though, there are values that are like truth E. They're not this, they're that. Okay, they're like truthoten, right? They're like truth E. Truth-ish, exactly, truth-ish. They're more here than here, okay? They're basically, the numbers are this. Think of it this way, 0 is considered falsy. So if you do if 0, that's considered falsy. So it will not go into this and it will not execute it. So 0 is considered more false than true, okay? So if you do const, num is 0, and then do if num, else, it will run this one. Right? Why? Because num, which is 0 in this case, is considered to be this way. It's false-ish, right? So it falls on the false side rather than the true side, and so in this case, if 0 is considered to be false, and so it goes into the else statement. There are others. Empty string. So suppose in num I put a string that has nothing in it, right? No space. Space is a character. If I did space, it's truthy. It has to be empty. So in this case, num is an empty string. It's quotes with nothing inside, right? That is considered to be empty. Think of it this way. If it's empty, 0, nothing, zip, nada, zilch, it's falsy, okay? So false, 0, empty, right? Those kinds of things are on the falsy side. Everything else is truthy. So what else is falsy? Well, there's a notion of undefined. What is undefined? Undefined means this. Remember how I had a variable and I put something in it? And a variable is like a box and you can put stuff inside. Imagine if I didn't. I still had a variable, the box, but it was empty, right? So you have the box, it's got nothing inside. That is undefined, okay? In JavaScript, empty is undefined. No value, there's nothing there, is undefined, okay? Okay, so if I write undefined, this is going to be falsy, therefore it's going to go into the else statement and print OK, okay? Of course, false falls under the false side, that's clear, right? False is, of course, makes this one false, goes to the else and prints console.log, okay. I think that also makes sense. There's another one called null that we're not going to use, so don't worry about it. The other one, though, is nan. You guys remember nan? Not a number, yeah. So nan is a value, and how can you get, like, where does nan come from, usually? Like, how do you end up with nan? Yeah, if you try to do an invalid arithmetic operation, right? For example, if you divide by 0, you get nan, right? It says that's not a number, you can't do that. If you try to multiply a string with a number, or a string with a string, right? These kinds of things are going to say, hey, well, you're trying to do math on something that doesn't make sense. And so it will produce nan, not a number. So if I were to put nan in here, nan, that's falsy, so it goes into the else and it prints console.log. It will not print this one. Right? It prints OK instead. Does that make sense? OK. Basically, other than 0, empty string, there's null, which you don't have to worry about, and false. False is, of course, false, right? Falsy. Everything else is true, truthy. More on this side than that side. Go.
How do you spell null?
Null, N-U-L-L. Okay, again, we're not going to use this in this class, null, there. In JavaScript, we'll only be using undefined. In other languages, null means what undefined means in JavaScript. To empty, like nothing there. But in JavaScript, it's undefined, so that's what we'll be using here. Those are falsy values. Everything else is truthy. All the other values, even if your text has space in it, look, if you do that, no, there. Notice I got ha. Now you might say, wait, it's empty. It's not empty. It has a space inside, right? That's a character. That means something. Empty literally means empty. there is nothing inside. If you have an empty string, then it's falsy. In all other cases, it's going to be truthy. Yes?
But what's the difference between falsy and false?
Okay, so false is a value. Literally, there's a value called false, like that. Like that, right? Which you can use here, and it will be false. There are numbers, like other values, like a number, 0. Which JavaScript, if you put 0 into if, it's going to assume it's false. But if you were to put in 5, it's going to assume it's true. Okay, think of it this way. One thing you can do, so 0 is falsy, right? We got that. Watch this. What do you suppose this will do? Okay, forgetting what this did. What does this do? What is the result of a Boolean operator? Boolean operator, what does it return? What kind of value? A Boolean, it returns a Boolean value. And what are the two Boolean values that we have? True or false. So this is actually going to return a Boolean value. So how? What it does is it figures out, is this here or here? Now 0 is more here, right? Flips it, but it has to return Boolean, right? So it does this and returns true. If you do this, it's going to turn falsy into true, and then it's going to turn true into false, and so num is going to be false. Make sense? Yes?
Is there like a situation in which false and falsy will be interpreted differently by the language, or are they basically the same?
In which they can be interpreted differently by the language. Yeah, there are. But the scenario I'm thinking of, I think, is a bit, hang on, let me try to think of a simple one. Okay, so the question was, is there a case where if a value is like false or, oh, I know. Yes, got it. We haven't talked about functions yet. Oh, okay, I know. No, I don't. Oh, okay, I know. Okay. You're doing, okay, age is a bad one because you can't be 0 years old. What can you have as 0? Bananas. No. Money. Definitely can have 0 money. Actually, you can have negative money. Okay. All right, so we have 0 money, right? And somewhere, so this is where someone is filling out a form, and they write their name, they write their age, and they write how much money they have. I know, it's stupid, just bear with me. They write how much money they have. Now, you want to make every field required. So you want to make sure that they've written something in every one of the fields, right? They didn't skip anything. You want them to give you all the information. So you say, if name would be a string, right? So it's truthy if it's there. If it's empty string, that means they didn't write their name, right? So that's falsy. Okay. But then you go if money, and you see that it's false. Is it false because it was empty, or because they put 0 because that's the actual value they meant? Right? That's an example where you can have this problem. Yeah. Good question. That was awesome. Wait, just I'll go.
What about both statements like if and else have contain something that is false-ish?
Right. So false. Right. So false-ish is interpreted in Boolean operators to mean false. So let me explain. So let's say so money is false-ish, right? Oh, or falsy, whatever. Okay. So we can go if money and true, whatever. Okay, so money is considered false-ish, right, or falsy. So this is here and here. That's easy. It's this, right, with and in between. Sometimes the mind works in a mysterious way. Okay, so it's this with and in between. What is the result of that? False, exactly. But if I did this, wait one sec. Actually, let me do this, false. Let me do or. And let me have this be not 0, but 10. What is 10? Is it truthy or falsy? Truthy, right? It's more here than here. Why? Because it's not one of the falsy values, right? It's not one of the like empty values. It's not 0, it's not undefined, it's not, okay. So it's here. So it's treated as truthy, therefore the Boolean operation will return true. Did I answer your question? Yes. Yes, sir.
We know that 0 is equal to 0 and false is equal to false. How is nan not equal to nan?
It's a mistake.
Well, yeah, but they're all false seeds.
It's a mistake. It's literally, okay, I agree with you. Logically, it's wrong, right? It makes no, how can you not be equal to yourself? It makes no sense. But this is a mistake that was written into the language when it was created back in 95, I think, 1995. And that mistake stayed. And the problem is the problem with languages is when you make a mistake, it's difficult to fix it because if you fix it, you might break someone's code who relied on the mistake. You see? So nan stuck. And again, yeah, the way to know if something is nan is to use is nan, which we have a video. I'm sorry? Null is equal to null, undefined is equal to undefined, 0 is equal to, everything else is equal to itself, yes, except nan. Yes, sir.
About that problem that you have to put the amount of your money,
Yes.
can you just refer that as a string? Will it still return false? Or?
No, you're right. The string containing the value 0 is not empty, right? It has a character which is 0. So you're absolutely right. Assuming you didn't cast it to a number, you could just say if, and then that would be a string which is truthy. Yes, sir. Yep, absolutely. Yes?
So if money equals 0,
Uh-huh.
we write money and triple equation mark and false.
Uh-huh.
True or false?
Okay. So watch. It's a very good question. So he's saying, suppose we have this, right? And then we want to do money, triple, false. Okay, so my question to you, is the value of money the same exact value as this?
No.
So what is the answer? That's the answer, okay? So in the same way that if, this was truthy, it would still be false because even though this is truthy, if we did this, it's not true. In the same way that if I compared that to, I don't know, this, 98 is truthy, right? It's not falsy. 1 is truthy. Of course, 1 is not equal to 98. They're two completely different values. The only thing they have in common is that, yes, they are truthy, in that they are more here than here. Yeah? Make sense? Okay. Yes, sir.
Where is nan is true or false?
Nan, falsy. Think of it this way. Again, just to help you remember, anything that means like bad, empty, nothing, like undefined, 0, empty string, like null, nan, like nothing. Assume it's false here. Everything else is up here. Yeah? It makes sense, right? Yes, sir.
What about negative numbers?
Negative numbers are truthy. Yes, sir. So literally, other than the values we discussed, everything else is truthy. Yeah? I answered your question. Were there any other questions? This is awesome. Keep going, keep going. More. That's it? Yes?
What if we have some empty value?
Yes.
And if we want to write some if-else statement and use if the value is empty, print this, and else if there is some value, print this. How we can do that?
Okay. So you want to check to see if money, okay, not money, name. So name has something in it. Boros. Okay. We want to know if name has something in it. If name.
There is empty.
Huh?
If there is something, it will work. But if there is nothing,
Nothing would be that.
name, but the box is empty. The const is empty.
There's no total.
Wait. Okay, so if there is no boros, not, which will flip the falsy to true, go inside the if statement, execute it. Make sense? The other thing you could do, of course, is just do, if name, and then do whatever you want to do if name is there, and then else, name is not there. Did I answer your question? Okay. Go. Who? Yes.
What about if we write the condition of else, something that is false-ish? What will the
So else, look, else doesn't take a condition unless you specify if after it. Okay, so if you specify if, so let's say name is empty, right? So of course this is going to be falsy, it's going to go into the else. Then here I can go if name and true. What do you suppose happens? What is this truthy? No, so it goes to the else. Is that if's truthy? It jumps over. It only, think of it this way. When they say go into the if statement, what they mean is if it's true, go into the stuff inside the curlies and execute it. It will only do that if the expression is truthy. Great question. Hesai, go.
Is there a need to write else statement after if else if?
Well, you could just create two separate if statements like this, right? But what this means, in this case, this if statement will only run if this one does not run. In this case, both if statements will be checked.
If we even write if, else if, after that we need to write else.
You don't have to. You can. If you want to handle that case, you can.
If we do not do that, it breaks the code also.
No. This is legal. What I wrote here is okay. You can do this. If you want to write an else, you can, but you don't have to. Else by Munchie at the end. But it handles like the default. You mean at the end here?
No, if we're just writing if.
Why not just write ifs? Why have the else if? Because they mean two different things. If you write if, like, for example, let's say, okay, watch this. Let me give you a practical example. Age. You have, the age is 19. You want to know if age is less than 21, console.log don't, do, I don't know. What can you do when you're under 21? I don't know, have fun, I don't know, whatever. Okay, and then you have another one. Age is less than 6. Log eat as much as you can. Is that what you said? Okay, so you have, et cetera, right? What this means is that this will run. It will check to see this. If it's truthy, it will run. It will then check this. If it's truthy, it will run. Yes? You understood that part. What this means, oh, sorry, one sec. There. What this means is that if this is truthy, run this, done. It will not check the next. The next if statement will only be checked if the first if statement is false. You understood the difference? You sure? Okay. Yeah. Vad sa inakem? Iherke. Yes. Ha. Eric, what's up? Yeah.
What's the difference between 2 equal signs and 3 equal signs?
Okay. Don't use 2 equal signs. Okay. Okay. For you guys, hopefully don't know or don't care, but just for you, with 2 equal signs, it does typecasting. So it can make two things that may not be literally the same value, but kind of look the same. It will try to make them the same, or you know what I mean, like the string 2 versus like 2, the number 2. I think in double it will think it's true, but it's not. That's bad, right? A string cannot be equal to a number, and it should not be equal. That's a mistake in programming. So whenever you write code in JavaScript, always use triple. Yeah, don't use type coercion. Yeah. I think PHP has a little bit of that too. Some languages do this, some languages do not. You just have to know the language. Yes. Oh, hang on. You're next, I promise. Go. Why do we consider zero falsy? So that's just how the language was designed. I don't know. I mean, okay, intuitively, I think I know what Brendan Eich meant. Is he was thinking, you know, hey guys, come on. He was trying to think, okay, if we want to see if a value has a value, like 0 is kind of 0, it's nothing, it's empty, maybe let's treat it more falsy than true, but anything else that is like 1, 2, whatever, it has a value, so let's treat, I don't know, it's an abstract thing. That's just how we decided. Yes, sir. Wait, you're next. You're next. Go.
So if we compare 1 with 2 with 2 equal signs, it will print false, yeah?
If you compare 1 with 3, yes, of course.
1 with 2 with 3 equal signs.
1 with 3, it will give false.
No, I mean with 3 equal.
If you do this, 1 compared with true, this is false.
And if we use 2 equal signs,
Okay, so see how it says have fun? Forget, I'm mad at you that you even brought it up. No, I'm kidding. Okay, right. Okay, stop. Forget what you just saw here. Never use double equals. Okay, just for those of you who know what that is, let me explain something to you. Why is it bad to do this? Because there's magic involved. And the problem with magic is you can't always count on it to do what you want. Let me explain. So for example, I'm guessing because you asked a question, knew that true double equals 1 is going to give you true. Did you actually know this? The person who asked a question? You knew that, right? Oh, you asked, I'm sorry. Did you know the answer? That true double equals 1 is actually true. Did you know? Okay, you knew that one. Do you know what happens if you do empty string double equals 1? Do you know what happens if you do empty double equals nan? Do you know what happens if you do string 2 double equals 2? You're guessing, right? You're thinking, maybe I know, but, right? This is the problem. Is even if you're the kind of person who sits there and reads all these rules and memorizes them, the other people reading your code are not going to know what exactly you want to do. It adds ambiguity. Magic adds ambiguity, which is why it's bad, because ambiguity makes it difficult to reason about something. Yeah? So for those of you who don't know about double equals, congratulations, never learn it. For those of you who do, forget about it. No double equals, triple equals. Yes? Good? Yes, sir.
Let's make it double equally չեն կարող օգտագործենք այն ժամանակ այն թողի example-ը։
Okay, կարող եք, բայց մի արեք։ Էլի եմ ասում։ Ինչի չեմ, okay, English, sorry. Why don't I want you to do this? Again, because in that particular case, you're right, but what if that value of that variable is something else? And I don't know the rule for what happens when you do double equals between two completely different values. And that can easily produce bugs, right? So be very specific about your code. And triple equals is exactly that. It's saying these two values have to be the same, or they're false. Right? Yes, sir.
So in case of and, it is true only if the two parts are true, right?
Truthy.
So if the first part is false, does it check the other part?
No, you're right. Yeah, so same thing with or, by the way. Or starts left to right, and if right away it encounters truthy, it's true. It doesn't even bother with the rest, yeah. Great question, great question. Anything else? Yes, sir.
If we don't write these else and write only ifs, this means that possibly we are increasing the time of loading a web page if we are writing.
Not so much. The problem with not writing an else is that you might have missed something. So for example, let's say you account for people ages 1 to 10, if, then else if 11 to 20, else if blah, 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 and then you're done, and then suddenly your program isn't running. You know why it's not running? Because you forgot 0 to 1. So else kind of handles everything else, right? It's all the things that you didn't have an if for. Yeah? It's like a default case. So again, you don't have to use it, but very often it's useful. Yeah? Did I answer your question?
Yes, but might be a problem associated with the websites of high loading.
Okay, so programs, as far as load time, we can talk about this later, but basically the biggest thing is file size. But at this level, like adding one line of code or not, that's so negligible. That's not, actually, when you're downloading a website, the biggest thing that takes time isn't the code, it's the images. So optimize those. Don't worry, the code is negligible. It's one line here, 2 lines there is not going to make a difference. Yeah? That answer your question? Other questions? We got it? Oh, yes, sir. Yeah. Or single, either one. Good question. Okay, so the question is, what happens if inside of this, or again, let me, yeah, you escape it, but let me, so there are a few ways you can do this. Const some string text, I'm putting in something like ABC, but I want to quote B. Well, if I do this, obviously the parser says, okay, we're going to start here, and we're going to end here, and wait, what's going on? And right, and it dies. It's a syntax error. So one thing you can do is known as escaping. You use a forward slash like that. That's how you do it, okay? Another thing you could do is, you know how we have 2 ways to quote? We have this and we have this. If you quote with this, you can now do this. And vice versa. If you do this, you can do that. Yes? Great question. Anything else? What time is it? Ooh. Interesting. I wanted to talk about functions today, but we only have... You know what? I'll give you an intro to functions. Wait, so conditionals. If, else, with Boolean logic. Any other questions regarding that topic? Because your next homework is going to have that, so just make sure you know. Are you sure you don't have questions? Last time.
May I ask one small question?
Go.
What's the difference between one quote and 2 quotes? Like,
No difference. No difference. It's a matter of convention. Like typically when I write code, I usually like to, if I'm writing HTML, the attributes I use double quote, but the string I do single quote. But that's just a convention. Like it's not a rule. That's just how I like to write code. You mean in ES6? Yeah, that's okay. Other questions or concerns or comments? How was your day? We're good? Yes?
So, for example, if, let's say, if someone is smaller than 21, I want to make 2 statements, like have fun and, let's say, drink.
Uh-huh.
So do I have to make, like, 2?
No. So, okay. Yes, I understand your question. So her question is this. Suppose we have an if statement. So const age is, 8, whatever. And we have an if statement if, age is bigger than 6. And then before what I did is I wrote a console.log here that says, yay, right, whatever. Notice how we have these curly braces, this and this. You see that, right? This means start, this means stop. I can write more stuff here. Etc., etc. So the answer to your question is no. You can, because we have the start and stop, in between you can write as much as you want. Çıkamaz. Did I answer your question? Other questions? As long as there are no more questions. There are no more questions. Yeah. All right, let's talk about functions. My favorite part. Truthy, falsy, we talked about. Conditionals, we talked about. Yay, we're done. Okay, next one. We have a box. It has a hole on both sides, but it's a magic box. 1 second. Okay. All right, it's a magic box. And from this side, I can give it some information. Some data, if you will, some values. So let me give it a 4, right? And a 5. Okay. Abracadabra, blah, 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 palm. And on the other side, I get a 10. That was cool. Okay. So this box, this magic box, knows how to take some information, right? Some data, some values, and then knows how to do some magic. And then the result of that magic, after doing something cool, is it can return some result, some value, which in this case is 10. So I gave it a 4 and a 5, and I got a 10. Interesting. Now, what did the box do exactly? Perhaps add 1, yeah, okay. Huh? Multiply, oh, what, who said that? What, say it again. Not bad. So it's a very good guess, and you guessed right, by the way. That's exactly what it does. Yeah, it finds the area of a triangle. Yeah. Okay, so it would be good then if this box, right, if rather than trying to guess what the box did, if it had some sort of a name, right? So let's give it a name that makes sense. So let's call it, area of triangle. There. Now our box has a name. And the name kind of tells us what it does. And we go, hey, that's pretty cool. We have this magic box, and anytime we want to know the area of a triangle, all we have to do is know the base and height, that is to say the two values, throw it in here, and then magically out the other side we get the result. Hey, that's cool. So any combination, any base and height that I give it, it's going to give me. Nice having a magic box like this, isn't it? Now imagine if instead of 1 I had a bunch of them. And anytime I wanted to figure out anything else out, whether it's the area of a triangle or Pythagorean theorem or whatever, I could simply pass in the inputs, and then magically I would just know the answer. It would just return the answer to me. Now it turns out that this magic box is actually not that magic. There is code that describes how it needs to behave. Ta-da! Okay, so some of this we've seen before. So we have something called base asterisk, which is multiply, right? Height, and then divided by 2. So this much we've seen before up until this point, right? What do you suppose these two things are?
4 and 5.
Right, so they're variables, which when I passed the inputs in, took on the values 4 and 5, right? The base and height. And in case you're wondering which one is the base, which one is the height, the name will tell you. That's why we have good naming, right? Is we have a variable called base and a variable called height. And notice this here, return. That's, return means return, in other words, push out this other side, the result of doing that. So again, we have a box. We take values, we throw them in. It executes this code and returns the result from there. That's a function. Easy. Easy peasy. Yes, sir.
Can I ask a question? In different languages like C++, there's a type of function like void that does not have a
It returns nothing, yes. Yeah.
Does this JavaScript have?
Yeah, you can just return, you don't have to return. Yeah, but for now, let's just assume there's an input and there's an output. Yeah. It's true. So, okay, a comment is you might have a function that doesn't need input. It just returns something. So for example, I don't know what time it is. I just say, hey box. And then it goes, and it's got what time it is, right? In other words, you can have a box that doesn't actually need something in order to figure something out. It can do that without me giving it values. If you want to know the area of a triangle, you have to know the base and height, right? How else do you compute? So that's an example of a function that would need inputs. But there are functions that may not require inputs. There are also functions that may not return something. An example, turn the lights on, right? I say turn the lights on, and I go flip the switch. It doesn't give me something, it just turns it on, right? So I have an input that I say, this is the light I want to turn on, and it just turns it on. It doesn't actually return anything. That's also a function. Again, underneath, it simply writes some code. So really think of it this way. At the end of the day, all a function is some packaged code. Packaged in a nice box with a name on it that you can use from your code anytime you like. Make sense? Questions so far about what a function is? You all understand what a function is? Yes! Woo! We understood conceptually what a function is, right? It's this box that has some code in it that maybe takes inputs and maybe takes outputs, but basically just runs stuff inside. How do we create such a thing in programming, in JavaScript? You want to say it? Yeah, okay, yeah. So there are a few ways to do it, but we're only going to learn one way here. Remember, so the way to create a function is to write the word function. Okay, now we want to specify what the values are going to be that the function will take, what the input is going to be. We open up parentheses and we specify the names of the variables. What variables went into that function? They had names, remember? Base and height. Then, remember in an if statement, we had like a start and end, and then the code in between. How did we specify start and end? Same thing here, the start of the function, the end of the function. Yes. Sorry, guys, come on, I can't hear. Go. Don't we have to define the what? No, you're defining them here. By doing this, you're basically saying create two variables inside of this function that will take the arguments, the numbers, that I pass to the function. You'll see it in one moment. Just wait 1 second. Okay, then we said, if we have a number like 2, we can refer to it by a name. How do we do that? Like age, which had a number. How did we do that? It's a variable, right? So when we want to put a number into a variable, we do const age 2 or whatever, right? So in this case, it's a function. So we can create a const, give it a name that makes sense. In this case, area of triangle, and then put in that function. And just as here, notice this semicolon at the end. This means end of expression. Think of it this way. You're telling the code to do this, then this, then this. Each one of these is semicolon. It's like the period at the end of your sentence. Yeah? It's the end of your command. So in this case, just as here we say age takes 1, end of command. Here we're saying this takes this function, end of command. Now we can write code inside. So we want to do base times height, and let's do this, and divide it by 2. And we can store that into some variable, const result, or area. And now we need the function to give us the answer back, to take the number out the other side, out of that other hole, right? We use the return command to do that. Return area. Return means return, give back whatever that is. In this case, it's the result of base times height divided by 2. Okay, so we have a function. We have this magic box. How do we call it? How do we run it? We refer to it by its name. There it is, that's the name. And then we call it by doing this. But then we have to give it numbers, right? We have to pass values into this hole. So we want to do what? 4 and 5? This will give us const result, which if we print console.log will give us 10. Yes, sir? Չէ, որտեվ const է հիշի, չես կարող փոխես։ Հա, բայց վար չենք օգտագործում, ես որ չես կարող։ And when ինչ որ ասացի, մջալուց վատ բան է։ Դրա համար հատուկ sense եմ անում, որ չկարողանաս այդ վատ բանը անես։ Գլոբալները վատ բան են։ Չէ, ավելի լավ return անես նոր արժեքը, հետո այդ արժեքը if սումդեմը օգտագործես։ Հետո խոսենք։ Other questions? Yes. Return 0 if you want to return 0. Okay, so an example. If we were to return 0 here, right, then the result of running this would be 0. And 0, I would go into here and I would do that. You could return anything else. You could return text. You could return hello world. And now the result of the running this returns hello world. And then that goes in here, and then that gets printed, and you get hello world. We will go over functions again. When are we meeting? Tuesday. If you have questions about functions until then, come to office hours, Google. There's a lot of material that you can use online. There are YouTube videos you can watch. You get the idea. Don't leave. We're about to take a photo.